Welcome to Samir Critic. So previously we talked about that how the advances of biomaterials comes into picture based on their response with the biological system. Now comes to the evolution or history of biomaterials. So about 2000 years ago, Romans, Chinese are basically use biomaterials such as gold. So first gold has used as the biomaterial or oral implantation, basically in case of oral implantation. Next comes to the turn of century, synthetic implants are comes into the picture. So that's mean the biomaterials which are synthetically derived, or those are not from natural origin. Now in 1937, polymethyl methacrylate, so commonly known as PMMA, introduced in the introduced as a biomaterials. So this is the one kind of polymer based biomaterials. So this is not any kind of metallic or ceramic biomaterials. Then comes to the 1958 Dacron fabrics used to fabricate arterial prosthesis. So this is very, very much emerging prosthesis sector. So first biomaterials. So previously it is something like xenograft, autograft, but Dacron fabrics in 1958 first developed arterial prosthesis with the help of biomaterials only. Now comes to the 1960. Camley uses polymethyl methacrylate and ultra high molecular weight polyethylene and stainless steel as well for total hip replacement. And late 1960 and early 1970s, biomaterial fields are much more solidified. In 1955, Society of Biomaterials comes into the picture. So this is the first biomaterial based society which is established in 1975. So this is a brief history of biomaterials. How the biomaterials comes from 18th century to 90s, and nowadays the biomaterials is much more bioactive basically. Okay, so now comes to the another part of biomaterials, that how with the year development of biomaterials taking place. Okay, so the various uh, development of biomaterials taking place at the late 18th to 19th century, and the development of biomaterials comes into the picture. So in 19th, 18th and 19th century, we are basically used as a gold and silver and platinum. Those are the basically ornamental element. So those are the basically used as a biomaterial implant. Now comes to the 1960, aseptic surgical unit comes into the picture. So basically from 1960 to 1980, it is taking place. Okay. So now comes to the early 90s, bones plate were introduced in the fixation of long bone fracture. However, many of those early plates broke due to bad mechanical design, or the strength of the mechanical design is very lean, maybe too thin, the stress concentration is very much more, or it will corrode rapidly with the interaction with the biological system. So in early 90s we are going through the much more greater mechanical strengths and corrosive resistance materials such as stainless steel and cobalt chromium alloys. Now comes to the year of 1930s. So we first introduced the stainless steel and cobalt chromium alloy as the implant, means biomaterials used as a implant or load bearing application. Next, 1932, first total hip replacement prosthesis comes into the picture. Previously, because basically we have used that the partial hip replacement, like this using screws and etc. But now the total hip prosthesis is comes into the picture. Now, then after 1940, we have used polymethyl methacrylate. So this is the belongs to the polymer group for corneal implant and replacement on the section of the skull bone. And in 1946, first biomechanically designed femurs heads replaced prosthesis taking into the picture, and basically plastic, not plastic, we are basically stained as a polymer or soft material PMMA, um, used in a joint replacement. Next come to the 1950s. First successful blood vessel replacements come into the picture. This is the blood vessel. Nowadays, blood vessel or the vascular grafts has been designed using 3D printing only, but previously it is made by uh, others technologies like as casting process or those kind of things. So blood vessel replacement is taking place. And lastly, 1960, first commercial heart valve replacement comes into the picture, and it is a cemented joint replacements. Okay. And basically from 1960 to 1970, the first generation of the biomaterials has been designed, and they was basically inert in nature, means they are not reactive with our body, decreasing with the potential of the negative immune response as well. So those are basically used as a supportive element in the body. Now comes to the in the 1990s. So the material design much more bioactive, they are very much interacting with the biological system, they are very positive manner in nature. So development of smart materials which can help and guide of biological response in the implant area. So this is nowadays we are basically talking about the biomaterials as a smart materials, like one kind of piezoelectric materials. So it can convert the energy from one form. So it is the bioactive one. So after replacement, the biomaterials is dissolved into the biological body and the new bones comes into the pictures. So we don't have to means it may be placed into the body one after operation. We don't have to go for another surgery for removal of that previous implant. So and design and the injectable material that can be applied locally with the minimum pain and the to the patient. So this is the relief of pain also. Now neat set of nanostructure biomaterials for nanoscale object are also comes into the picture using reinforcing agent or as a reinforcing agent. So that is all about the basic history of the evaluation of biomaterials. So next day we will talk about origin of defects in the body and how the defects come into the picture, and from what point of view we think about that we have to go for biomaterials or we have to go for some supporting uh, element that so that the defect of our body can be prevented. So thank you class.